You and I rely on bridges in everyday life. We trust engineers to design them to be strong enough to carry cars and trucks. However, bridges usually deteriorate from environmental factors, not vehicles. Recently, the Genoa Bridge in Italy tragically failed, and sadly, 43 people lost their lives. Why did it collapse? Preliminary investigations show that it was because the steel bars inside the concrete corroded, or in another term, rusted. Steel bars strengthen concrete, but they corrode over time, and therefore shorten a bridge's life. Could that failure in Italy and others around the world have been prevented? Can we make our bridges last longer? I'm sure the answer is yes. Florida has around 5,500 bridges. 2/3 of them are in marine aggressive environment. We are surrounded by salty coastal water. Seawater gets on the concrete, chloride ions penetrate through the concrete and reach the steel bars. Then the steel bars corrode. And remember, rust never sleeps. The corroded steel bars expand into the concrete, causing the concrete to crack more, as you can see in the picture. The corroded steel bars become less protected, which furthers corrosion. As a result, the bridge is weakened. Stainless steel cables have a higher tolerance to chloride ions and could extend a bridge's life to 100 years or more, about double the life of a bridge constructed with black steel cables. So, we have found a solution to corrosion: stainless steel. But what about the strength of stainless steel cables inside concrete? My dissertation will investigate this. Imagine standing under a bridge and it suddenly fails without warning. This is not good. Engineers design bridges so that you would see them deflect before they fail. This is called ductility. Taffy, the candy, is ductile because it stretches before it breaks. Stainless steel cables don't stretch as much as black steel cables before it breaks. For my research, 5 full-size bridge beams have been constructed. They were all reinforced with stainless steel cables. You can see one of them in the picture. We have been testing them in a lab to determine their ultimate strengths. Then, I will develop equations that engineers can use to predict the beam's strength. I will make sure that if the beam is overloaded, it will deflect and give warning before it breaks. With this research, I'm studying the use of stainless steel cables in bridges, which will reduce maintenance costs, increase bridge life, and most importantly, be safer for people. Thank you.